Hold on. We took the PSAT on Tuesday.
Okay.
Some of those questions are kind of hard.
Yes, indeed. I've been tutoring a lot of students on the SAT or the PSAT. They're equally hard. And I'm kind of amazed at how much more difficult the test is since they revamped it in 2016.
Yeah. Wait, do you know, like, do you think we could actually just go over some PSAT stuff, honestly?
Absolutely. In fact, I've got access to 7 practice tests online.
Let's do that, because I don't know if I have, like, a worksheet that I can do right now.
Yeah, no, that's fine. I'm always willing to do whatever you feel like working on.
Okay, sweet.
Even though it seems like we probably should have done this before you took it, not after, but that was just a PSAT. So you've never taken an SAT?
Well, no, not the real one.
Okay, well, that's fine. Let's start with 1.
Yeah.
And this practice one is the one produced by College Board, the makers of the SAT test.
Okay.
Now, if any of the practice tests are going to be more legitimate, then there should be. And I'm going off of that assumption. I'm assuming that this company that makes this practice test does not sell tutoring services.
Yeah.
Because you wouldn't want that. I've seen Kaplan do that, where they'll put some practice questions up that'll all be super hard, and of course makes you think you're stupid and you need to take their course.
Yep.
So that's why they do it. So I'm a little suspicious of Kaplan, but I think this outfit, these practice tests are probably more representative. Although I did have a student tell me that these practice questions here were harder than a recent SAT test that he took. So I don't know. You got both opinions.
Yeah.
Hold on, I got a new technique here that allows me to do the following.
But I kind of figured, like, I'm probably going to take the PSAT, like, 2 or 3 more times before I take the actual SAT.
Okay.
Because, you know, like, I'm always hearing stories about people that take the SAT, like, 2-3 times before they actually take the SAT.
Well,
and they seem to do pretty well.
Well, practice makes perfect. I mean, it does. So the more time you put into it, the better off you are. And in fact, I would encourage you to, if everything's going well in your math class, let's do a session where we just do SAT. We could do that for the next 2 years. You're a sophomore?
Yeah.
Okay. So you'll be taking it for 2 years. Between the PSAT and the SAT.
Yeah.
But yeah, there's, in my opinion, there's really no better way to teach math than doing this. At least you're talking algebra and geometry. These tests don't get into trig or precalc very much. They get into trig a little.
Yeah.
But just very basic trig.
And I think it's pretty, like, it's nice that it covers, like, a lot of different stuff. I guess.
It is. And all of these problems that I've noticed on these tests here, they tend to require 3 or 4 different knowledge of different math principles in order to solve. Although not all of them. This first one's pretty easy. You see it okay?
Yeah.
Okay. If you know how to do a problem and you just say the answer, I'll just go on to the next one.
What is the value of x? Hold on. So wait, wouldn't x minus 1 over 3 just be equal to 3 then?
Uh-huh. Now
So,
solve that for x.
Yeah. So, oh crap. Okay, I know what to do. 10. It'd be D, right?
Yep. Okay.
I don't know. I was overthinking that. I was like,
That's all right. Sometimes there's, especially when you've come out of geometry or something, it's difficult to remember a year back some of the algebra. Same thing,
yeah.
once you get beyond geometry for a year or two, remembering some of your geometry is going to be tough.
Oh yeah, during the PSAT I got a question about sine and cosine and I completely forgot how to do that stuff.
Yeah. Yeah. We won't worry about that too much because you're going to be taking trig between now and when you actually take the SAT. So trig will be one of your more recent maths that you will have taken right prior to the SAT. So you'll be fine with the basic trig questions they ask you.
Yeah.
I'm not going to worry about that too much now. All right, imaginary numbers. You probably haven't had much in the way of imaginary numbers.
Well, we've had the I's and stuff.
Okay, do you know how to add this complex number to that complex number?
Do you distribute it, right?
No, you're adding them.
Or do you, not distribute it, do you, put the plus into the, oh wait, no.
You add the reals and you add the imaginaries separate.
Oh, that's, okay, that's it.
Real easy. In other words, you add that to that, you get minus 1, and then you add 3i to 9i, and you get plus 12i. Now, you're correct. You needed to distribute this plus sign, but basically the way to distribute that plus sign is just to erase all parentheses immediately.
Yeah, because the plus sign wouldn't change anything.
Exactly. If that were a negative sign, then I can't just erase all parentheses. I got to distribute it to each term. But as long as it's a plus sign, then you can pretty much ignore the parentheses.
Okay.
That's the answer. Okay, how about number 3, upper right?
Yeah. On Saturday afternoon, Amanda sent. Is that sent, right?
Uh-huh.
M texts messages each hour for 5 hours. Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Amanda and Tyrone on Saturday afternoon? So 5M plus P4, right?
Good.
So C.
Yeah.
Wait, does it? Oh wait, no, never mind.
Okay. Now I'm going to suggest another method to do this just because it's such a great example of this other method. And a problem like this that just involves multiplying a number by a variable and adding it to another number multiplied by a variable. You can generally figure that out pretty easy. But they throw a third variable in, and if division is required, in other words, frequently if you have to multiply and divide, then it really becomes difficult to get your mind around it.
Yeah.
Okay? So there's an excellent method. If your life depended on you getting this problem correct, I can give you a method that you'll always get it correct. Okay, and it's called picking numbers and back solving.
Okay.
And you do it, the thing thing you're looking for to use this method is when you have variables in the question and you have those same variables in all four answers.
Mm-hmm.
And what that means is that your answer has to be true no matter what M and P are, right?
Mm-hmm.
So the way I'm going to go about this picking numbers is I'm going to pick a nice simple number for M, 2, and I'm going to pick a nice simple number for P, which is 3. And now I'm going to go through the problem, and I'm going to say, okay, if Armin sent 2 text messages each hour for 5 hours, that's clearly 10.
Yeah.
And if I use the same logic for Tyrone, that's clearly 12. So I can easily and certainly figure out that they sent combined 22 text messages.
Mm-hmm.
Now, I can go through each answer until I find 22. In other words, for A, I'm going to substitute 2 and 3 for M and P, but I get 54. So that doesn't work.
Yeah.
B, I get 100. That doesn't work, or 120.
Yeah. And then 5.
C, I get 10 plus 12, I get 22. And D, I get 8 plus 15, I get 23. So if I wasn't 100% certain, and I needed to be, you can always use this technique. Now, granted, these tests are speed tests. So you have a little over about 2 minutes per question on average, or a little under 2 minutes per question.
I thought, wait, isn't the whole thing, though? I thought it was under a minute per question, honestly.
Here, let's back up and look.
Yeah, because it says the amount of time, right?
Whoops, hold on. I got to do this first. There. You're right. Well, it's a little over a minute per question. 25 minutes for 20 questions. Yeah.
Okay.
Not sure where I was getting that other from. 25 minutes for 20 questions. So you got about a minute and a little bit more.
Wait, but I have a question.
Okay.
I think it was on the PSAT. It might have been on a different test, but on the PSAT, I got like say we go back to the question that we were just doing, right, with the 5m plus 4p, right?
Correct.
Well, I got a question, and there were 2 answers that had 5m plus 4p, and then the other one was 4p plus 5m.
Right.
So they were the same thing, just in like order, and I had no idea.
Right. Okay, let's talk about 2 things there. If indeed they gave you exactly the same 2 answers, then it's a typo. In other words, they are never going to give you a question that has 2 correct answers.
Yeah, okay.
Without it being a mistake on their part. Now, however, you bring up an excellent point on this picking numbers technique. If I'm unlucky enough to pick incorrect numbers, I could find 2 of these answers. It would have been possible to find 2 answers that both gave me 22. Hold on, let me bring it back up here. And what you do when that happens is, let's say with the numbers I picked, M was 2 and P was 3, and the total number of texts sent were 22. And I go through here and I get 22 for this one, and I also get 22 for that one. And that is possible. If you are unlucky enough to pick 2 numbers that happen to produce 2 answers that both give you the correct answer. If that happens, there's a very simple solution. Go back and pick 2 different numbers. That's all you have to do. In other words, go back and pick 3 and 4. Or
Okay.
Or maybe, I'd stay away from 0 and 1, but just pick two different numbers, and then the only two you have to differentiate between are those two. In other words, you
Okay.
don't have to use your new numbers and go completely back. We've definitely shown that A can't be right and B can't be right. So
Yeah.
when you go back and you pick your new numbers, you only have to test the two that both gave you the answer 22.
Okay.
That will occasionally happen. But
Yeah. I'm only asking because like I think it was on the PSAT. It might have been on just a regular math test. But I ran into like a problem where it was like it's just like the same thing but just switched around, and I was really confused looking at the answers.
right. There is
So,
one thing, let me say, about the SAT test, is you're not trying to convince anybody of your math knowledge here. That's not the goal. It's not like a math class where a teacher might go through your work, and if your work is all good, she may not take off as many points if you happen to, make a mistake. This test, there's only one purpose and one purpose only, and that's the highest score you can get.
yeah, the accuracy.
So it's not always correct to plow into the math, and that's what everybody's tendency is. In other words, when they give you a word problem that's algebra, everybody wants to immediately go through all the algebra, but that isn't always the best way to answer the problem. In other words, it's a question of getting the problem done in the least amount of time, first of all.
Yeah.
But another is you're not trying to impress anybody with your algebra. You're just trying to get the answer, and that's all you need to do. So there's a lot of questions where I really am a firm believer in back solving if it's appropriate for that question.
Yeah.
Now, it seems to me like this new SAT test, they don't have as many problems that lend themselves to back solving. It's almost like they wanted to remove that with the newer test. But maybe not. I might be proven wrong. How about number 4?
Okay. Kathy is a repair technician for a phone company. Each week she receives a bath. Actually found that. P equals 108 minus 2. Wait, hold on.
Best way to get a grasp on a problem like this that you're having trouble with, make up a number for D. See
well, this problem's dumb because it says, hold on, it says where P is the number of phones left and D is the number of days she has worked that week.
Okay.
She's worked 23 days that week, and there's only 7 days.
Make up 0 for D. What happens? What do you get?
0.
In other words, she hasn't worked any yet. What happens?
Okay.
What's P equal to?
108.
That's the number of phones she starts the week with.
Okay, so
If you let D equal 1,
then it's
P is down to 85. That's because she repaired 25 phones on that first day.
Yeah, okay, that makes sense. So it's the amount of phones that she
started.
Yeah, okay.
So it's B. Answer B as in boy.
Yes, starch. Okay.
Okay, all right. Let's go down to the next set. Now, also, I was just thinking that this is the non-calculator portion, and the rate of time per problem might be different.
So I took the PSAT, the calculator section was way harder than the non-calculator
Yeah, no,
section.
I know that they're definitely different. I'm just not sure if they change the amount of time they give you per problem.
I think they do, but I think like we got 35 minutes for the calculator or not. I can't remember.
Well, we'll find out because there's not that many more questions for the non-calculator portion.
Yeah.
As soon as we get to it, they'll have instructions as to how many questions and how many minutes.
Yeah.
So we look at number 5.
Which of the following is equivalent to the expression above? Oh, this is just combining like terms.
Absolutely. What's the first thing you want to do,
Uh, do you want to distribute it?
Yeah, you want to basically remove parentheses.
Or remove the parentheses? Oh, so distribute the negative, I mean.
Exactly.
That would be
In other words, I can remove the first set of parentheses without changing anything, and usually that's the case. That's almost always the case.
Yeah.
It's the second set that are difficult if they're being subtracted. As we saw in a previous problem, if that's a plus sign, then no problem. You can just remove all 4 parentheses without changing anything. But we have to change it. So tell me what to write. I'll get you started.
So,
Hold on a minute. Let me get the first part. All right. Now what else? What's left?
actually, hold on. So, wait, sorry, is that the first one? Yeah, that's the first one. Okay. And then after that, you distribute the negative to the second pair of parentheses.
So
And
tell me what that creates, yes.
So that's plus x squared y minus 3xy squared minus 3y squared.
Plus 3.
Or plus 3y squared, I mean, sorry.
Okay. Now, these are a little tricky because, boy, everything looks the same. You know, you got to distinguish between the x squared y's and the xy squareds. So the way I usually combine like terms is I take the first one and find everything that looks exactly like that, do that first.
Yeah, and that's 2x y, or 2x squared y.
And then with a big long problem like that, I find it helpful to cross it out after I've done it, because otherwise you can forget some. Okay. How about the next the next term we encounter? How many of those are there?
0.
Okay. And leaving
2xy squared. So it's C.
Right. Correct.
God, yeah.
Okay.
At first when I was reading the problem before you kind of said it all out, I was trying to do that in my head and it just got really hard to distinguish.
I know you could probably do it. If somebody, your life were at stake, you could probably get that whole thing in your head and get it correctly.
Yeah.
Just not sure whether it's worth the risk. In other words, it's an easy problem that if you take your time, and you're not going to miss this problem, ever, hopefully.
Yeah.
So you would hate to miss it just because you were trying to do it in 20 seconds instead of 30 seconds. All right, how about 6?
6, a pediatrician uses the model above to estimate the height, age of a boy in inches. In terms of boys, age A in years between the ages of 2 and 5 based on the model. Where does the estimate increase in inches of the boy's height each year? So, is this one of those things where if we put it to 0, A equal to 0?
Actually not. The best way to tackle this problem is to know, first of all, you're looking at the equation of a line. Let's graph it. And this doesn't take long to do. When I say graph it, I mean approximately. In other words, you don't have to put an elaborate grid system on it. That's all you have to do on your scratch paper is that. Now, what do they mean by this is the height, and this is the number of years that go by in time, or sorry. Okay, in terms of the boy's age, A in years. So, what are they talking about? Aren't they talking about rise over run?
It's definitely...
They want to know how much the height changes
in one year.
In 1 year. That's rise over run, and that's the slope.
And that's fine. Couldn't you just basically put A equal to 1 and then just distinguish that it's 3?
Yes, you could. You could put A equal to 1, although it says between the ages of 2 and 5. So,
between the ages.
Yeah, probably the fastest way to do this problem, if you don't realize that they're asking what the slope is, because the moment you realize they're asking about slope, well, you know that 3 is the slope. But you're right. The best way to do it maybe would be to put in 2 for A, and then put in 3 for A, and then there's a 3-inch difference.
Yeah.
And bingo, you're done. You don't have to do any of this other stuff. So whatever way works and gets you the answer the quickest and the most accurate, that's what you want to do.
So would A actually be the answer then?
Yeah.
Yeah, okay.
Yeah, it's definitely, they're asking about slope. And the slope is clearly 3. Now, next problem is really kind of a clever problem. Scarier than hell when you first look at it.
Yeah.
It's actually an easy problem. You just have to be careful about what you do. Now here's one where I said that the people that just plow into the algebra, my God, you could spend 20 minutes trying to do the algebra on this problem.
Yeah.
And none of it's needed.
Yeah, because it's not asking for the answer.
No, it's asking you to solve that equation for P. Well, what if I told you this? M was equal to A times B divided by C times P. And I said, solve that for P. What do you get?
You would get A times A, or M times A, B over
times
C.
A, B times C.
Oh, times C over AB?
Well, the first step here is to get rid of the denominator. So I'm going to multiply both sides by C.
Okay.
Okay. And that'll get rid of that. And I got to divide both sides by AB. And in one simple step, I've solved for P. As long as I have something where I've got 2 multipliers in the numerator and 1 divisor in the denominator, then this is a piece of cake to solve for.
So would it just be A then?
Well, you're correct, and this is the same problem as what I just drew. The difference is that's A, that's B, and that is C. So what we're looking for in the answer is whichever answer has this in its numerator, because our first step is to multiply by that. Well, that looks a lot like this.
Yeah.
And this in its denominator. And that looks a lot like that. So it's actually a very easy problem. Note No algebra required. Well, there's algebra required in solving that equation for P, but
Yeah.
you don't have to get involved with all of these fractions and 1 plus fractions. And notice something else. They explained to you what P was, what R was, what N is. In other words, they gave you all of this useless information,
Yeah.
none of which was needed. So don't fall for it. Just because they give you information doesn't mean it's relevant information in order to solve for it. If I tried to solve that any other way, it would be a nightmare. In fact, I have no idea how you would do it. Because
Yeah.
the combination of a rational quotient times an exponential equation, down in the here we got an exponential minus 1, that'd be a nightmare to solve. If they wanted us to solve for any of these variables, and give us the rest. But if I'm just solving for P in terms of M, then it's a real easy problem.
Yeah. And it's basically just like flipped, right? So if I run into a problem on the SAT like this, should I look for the one that's just kind of flipped, like opposite?
Well, you want to know this principle. You want to know that if I've got x equals a over c times y, then to solve for y, I'm basically going to multiply by the flip. In other words, I'm going to multiply both sides by c over a. If I want to do it in one step, that's the way I do it.
Okay.
Okay? You can always multiply by the reciprocal. The idea is to get rid of this a over c, whatever you have to do. Now, a little easier to see it as multiplying by the denominator and then dividing by the numerator, but that's the same as multiplying by the reciprocal. Okay? Because that c cancels with that a cancels with that, so I'm left with y equals c over ax. So the one skill you definitely want is the ability to solve an equation. When they give you an equation that's x equal a bunch of stuff times y, you want to be able to solve that for y, for sure.
Okay.
Interesting one. They definitely make some interesting questions here. Again, let me get it. I can draw on it. Boy, it shrinks it just a tad bit when I do that, doesn't it?
Yeah.
Can you still, is it still high enough resolution that you can see it on your end?
Yeah, no, that's fine. If a over b equals 2, what is the equivalent of 4b over a? So that has to be 2, or can we put a over b as equal to 2 over 1?
Yes.
And then make it so that that's 4 1 over 2.
Well, hold on. So this is your first step. And then now do what?
And then can you flip that basically because it's asking for b over a?
That's what I was looking for, yeah. In other words, that necessarily means this as long as there aren't zeros involved.
Yeah, okay.
In other words, if a can be 0 in this top equation, but a cannot be 0 in the bottom. So if a is 0, you can't flip. But if there's nothing but real numbers involved, then yes, you can always do this. And now, what's 4b over a?
It's 2, right? It's c?
Yep. All right, next one. Solving simultaneous equations. And again, there's a couple of ways to do this problem.
I know there's a, oh crap, I can't, this is like 8th grade. This was like 2 years ago. Okay. But isn't there a way to actually plug it in?
Well, that's one way to solve the problem, actually. It might not be the quickest way. Let's go ahead and try that. See if you can solve the problem by back solving. You know what I mean by back solving?
By like plugging it in like what I just said, or no?
Yeah.
Or
in other words, start with the answer. Any of these answers are liable to be just as valid, right? So we don't have anything to really go on in terms of which one to start with. So start with A. Plug it in. Does it even satisfy the top equation?
Let's see. So that's negative 15, and that's negative 8, and it does.
Okay, now it has to solve the second equation, and if it does, it's the answer. Because like I said, they're never going to put two correct answers on here. In other words, they're never going to give you a situation where it could be A or D. In other words, if A works, we're done with this problem. We are not going to waste our time testing B, C, or D.
And it does not equal negative 19.
Okay, because that's negative 10 plus 2, okay?
Yeah.
Now let's go to the next one.
So 3, so that's 9. 9 minus 24. That's...
Hold it, 9 minus 32.
32.
Okay.
Which does equal negative 24.
Okay. Now the second equation.
That's 6 and 6 plus, that doesn't equal 19.
Okay. Now, you should be starting to see the downside of this method.
Yeah, it takes a while because you go through all of them.
Takes a long time. We will eventually get there. Let's go ahead. It's worth taking it to conclusion.
So, 4 times 3 equals 12, yeah, and then 6 times 4, or negative 6 times 4 equals negative 24.
Okay, good. That wipes that one out. Don't have to do any more work there.
So then it has to be D.
Yeah, we're actually done. And the only thing about declaring this problem finished and going to the next, which I would probably do if I was taking the test, is the confidence you have in your arithmetic. In other words, you need to be 100% certain that you didn't make any mistakes.
Yeah.
And if you're only 90% certain, then it might be worth the extra 15 seconds to test this thing, at least on one of them. It depends on how fast you are. 27 minus 24. Wow.
Did none of those equal 23? Negative 20, or I don't think any of those are the solution.
No, that's never the case.
Did we miss something?
That means we made a mistake. Or did I just do my math right? 9, that's 27.
Yeah, no, that is 27.
24. Yeah, that's not negative 23, so D is not right. And now it really becomes problematic in figuring out where we made our math error. You might actually have to start from scratch. And that is the problem with back solving. Okay? And that's why I would not use back solving on this. Let's go back to solving by elimination.
Okay.
Elimination is my favorite method. But in order to use it, everything has to be in standard format. And the second equation isn't quite in standard format. I got to switch the x and the y position.
Yeah.
But that's all. In other words, I want to get it so those variables are lined up under one another. Okay. Now, we're going to eliminate a variable. Well, what do I have to multiply equation 2 by? That's equation 1, that's equation 2. What do I have to multiply this by such that I will be able to then add the two equations and one variable will go away?
So what we're basically trying to get is to the point where 3x plus 4y and negative x plus 2y equal the same thing.
No, here, let me tell you. I'm going to multiply the second equation by 3.
Yeah, okay.
You can always multiply one side of an equation by anything you want as long as you multiply the other side.
Okay.
Now, that gives me a new equation too. That is minus 3x plus 6y equals minus 57. Okay? Cross out my old equation 2. Now, if I add these two equations together, what do I get? You can always add equations or subtract equations. You're always allowed to do that.
You get 10y equals negative, what is that, 80?
Which means y equals
8.
Now, notice something really sweet.
Yep, there's only one 8.
You don't have to go back and solve for x. Normally, you would have to go back and finish solving the thing. But since they only give you 1 minus 8, we're done.
And there's only one that has a y of negative 8.
Correct. So we're done with the problem. So
what did we do wrong with the back solving?
Well,
I'm just curious.
I don't know. Let's take a look. Now that we know the answer, just did our math wrong. When I plug in b for the top one, I think it worked. It was 9 minus 32. Yeah, that was negative 23.
Yeah.
I tried it. Oh, I know what I did. I plugged the wrong one, and I plugged the x value in for that second one, which is an easy mistake to make, notice.
Oh, shoot. Yeah, I was doing the same thing.
Yeah, you got to plug the y value in, which gives you minus 16 minus 3 equals
3.
minus 19.
I was doing the same thing. I was doing 3 times 2.
Exactly that same thing.
Yep.
Wow. They are tricky.
Damn.
In other words, they were really kind of punishing back solvers here.
Oh, yeah.
They were definitely rewarding people who remembered how to solve these elimination, because it didn't really take that long. I mean, if you remembered what you were doing, you would have solved that in 30 seconds, I think.
Yeah.
Certainly under the average length.
Yeah, that was pretty easy.
Yeah.
Okay, what do we got? 11, right?
Let's go back. No, yeah.
Yeah.
What happened to 10? No, let's do 10. Let's do them in order just so we don't get mixed up. In fact, let me blow this up a little bit so that when I do take a picture, it won't be so small. Hold on. No, maybe we'll do 10 and 12 and then go back and do 11. But anyway, let's see if this needs any effort at all.
Yeah, for the function g defined above a is a constant and g4 8, or g4 equals 8. What is the value?
G of 4 is the correct terminology. It's not multiplication. You're not multiplying g times 4. It's the function evaluated at x equal 4. That's what that means.
So that means that g has to equal 2. Right? So g negative 4 would equal negative 8. Right?
No, but you're on the right track. You got to be careful with some shortcuts. First of all, g of 4, oh, hold on, sorry. Sometimes I forget whether I'm in draw mode or not. There's a couple of ways to do this problem, as most of these problems there are, and I like that about it.
Oh, are you going to plug the numbers in?
Well, first of all, that's equal to 8, and g of 4 is when I plug 4 in for x. So I get a times 4 squared plus 24. That allows me to solve for a, because now I got 8 equals 16a plus 24. A ends up being minus 1. Now that you know a, here's the function. It's g of x equals minus x squared plus 24. And now if I want to plug in minus 4 instead of 4, I'm going to get minus 16 plus 24, or an answer of 8. That's the surefire, slow method of doing the problem.
Okay.
But probably the one that most everybody should use.
Yeah.
And that's to solve for A, and then go back, and now that you know, in other words, we didn't know the full equation at first. We knew everything, but we didn't know A.
Yeah.
So this information allows you to solve for A, then you know the full function. Now you can plug in a new number, minus 4, and figure out what that is. Now, it's not accidental that these two answers are the same. The fast way, if you happen to notice it, is that if you realize that it's not going to matter whether I plug in 4 or negative 4. I'm squaring it.
Okay.
So
wait.
G of 4 has to be the same value as G of negative 4.
Yeah.
Only because it doesn't matter if that number is negative or positive. I'm only plugging it in one place, right? Can you see where I'm pointing with my pen?
No, I can't.
Can't, okay. I'm pointing right there. That's the only place I'm going to plug in that number.
Okay.
And it's going to be 16 whether I plug in 4 or negative 4, correct?
Yeah.
So G of 4 has to be the same as G of negative 4. Nothing else is going to change. And I don't really have to solve for A. In other words, as long as I can see. In other words, if this was my function, G of x equals A times x cubed plus 24. Well, now I'm going to get a different answer. Let me just even say that's a 1 there, okay?
Yeah, one's going to be negative.
G of 4, well, 4 cubed is 64, but if I plug in G of minus 4, minus 4 cubed is negative 64.
64, yep.
So I get a completely different answer when I plug in a negative number as opposed to a positive number. But if you're squaring it, and it doesn't have to be just squared, it's to any even exponent. That could be x squared or x to the 4th or x to the 6th. In which case it will not matter which of these two numbers I plug in for x. I'm going to get the same answer always.
Yeah. Okay, so the G... So the G for both, when it says G4 equals 8, then... Hold on. So is A the answer?
Hold on. Let me start here. Very important.
Yeah, okay.
Very important that you understand this concept for most any higher math.
Yeah.
What is f of 2?
F of 2 is 2... Well, it's going to be 4 plus 1, so 5.
Hold on. Do the math.
Wouldn't it be 2 plus 1? Oh,
do that first. That's 3.
3 squared, 9, plus 1 equals 10.
Okay. So now, let me ask you another question. What is f of x plus 2?
F of x plus 2, isn't that... oh wait, no, that would just be...
Here's what you do. Whatever is inside the parentheses, I plug in for x in the original function.
Yeah, so it'd be...
It's going to be x plus 2 in parentheses.
Yeah, and then plus 1 squared.
Squared.
And then parentheses squared plus 1.
Okay. Now, I don't care what that answer is. The concept is what's important. That means that it doesn't matter whether you have numbers, whether you have variables, whether you have complicated variables. I could have an x squared plus 1 all divided by square root of x. Well, that's no harder than my problem. I just take whatever's inside the parentheses and I plug it in wherever I see x. Simple, period. Okay? So, that's this problem that we're doing over here on the other page, that's what f of 4 means, is you're going to plug in 4 for x. Even though we don't know what a is, we don't care. Because when I plug in minus 4 for x, I get the same expression. I get 16a plus 24 in one case, and I get 16a plus 24 in another case.
Okay.
Well, if you tell me that that one's equal to minus 8, I don't have to do any math to know that this one's equal to minus 8.
Mm-hmm.
All right.
But the answer would be 8 for that one?
Correct. Positive 8.
So would you replace G? So if you wanted to plug 8 back in, can you do that? Can you plug 8 in for G?
Not for G. Here's what you have.
Oh, is it?
You have
Oh, I think I know what it's
X. Okay. We did it the hard way. But if we were doing this the traditional way, we solved for A. It was minus 1.
Uh-huh.
So this is the function. Now there's no unknowns. That's our function. It's a quadratic.
Mm-hmm.
So if I want to know what g of 4 is, if I want, let's plug in minus 4, since that's what they ask about.
Yeah.
Well, then it's minus, and be very careful in situations like this. You do not drop a negative sign.
Okay.
Right? In other words, I'm plugging in minus 4 in parentheses wherever I see x. Okay, well that's minus positive 16 plus 24, that's equal to 8. So yes, we checked, make sure g of minus 4 was equal to 8.
So, okay, I don't know why I just couldn't get past the fact, like,
that's a tough concept. A lot of people have trouble with this function notation.
Yeah, I was misunderstanding it. I thought it was like 8 times 4 equals 8. I thought that's what I was saying, but it's not. It's...
Notice the difference between function notation and y notation.
Mm-hmm.
Over here on the right. We know that y is the same as f of x, correct?
Yes.
And they are. One is just a different way of writing the same thing. But there's lots of advantages to the f of x. For one thing, it tells you it's a function of x, whereas this one doesn't. I don't know what variable I'm going to find on the other side of my equation when it's y equal. Could be r, could be t, could be x. In this one, I know it's a function of x. X is the only variable I'm going to find. Furthermore, it allows me the luxury of doing stuff like, well, what's that? And then I can evaluate the function at that number. Okay, it also allows me to evaluate the function at strange things like this, which you get into with calculus, and that's 2 times x plus h plus 5. So that concept is very important in higher math, is that whatever is inside the parentheses gets plugged in for x. And just to be safe, always use parentheses when you do it.
Mm-hmm.
Okay?
Okay.
All right. Let's go up and not skip 11, because 11 is probably going to be the last one we're going to get to tonight.
Yeah. In the equation above, B and C represent the price per dollar or per pound and dollar of beef and chicken, respectively. X weeks after July 1st during last summer, what was the price per pound of beef when it was equal to the price per pound of chicken?
Make one other recommendation, Simon, and that's that when you do these, read them silently, merely because that's the way you're going to read them when you're taking the test, silently.
Yeah.
You're not going to read them out loud. Everybody's looking at you in the room if you did. So it's a very subtle thing, and the only thing I try to do when I'm working with students to, practice for this test is to get them to get themselves in the exact same position they're going to be when they take the test. Meaning have your calculator at hand also. Have a scratch sheet of paper and a pencil at hand. Although generally I like to do everything verbally on my screen, still there are going to be situations where you're going to want to be in the same exact situation, other than having 35 other kids in the room, that you're going to be in when you take the test.
Yeah, okay. Yeah. It's good to practice the environment.
Yeah, no, I mean, if you're trying to win Wimbledon, you want to practice on grass courts.
Yep. What's the price per pound? So now we're just trying to find what x equals to see where they would both equal each other, right?
Exactly. That's the key thing to know.
Okay.
Okay. And what's the equation that I need to write?
Do you do 2.35 plus 0.25x equals 1.75 plus 0.4x?
Correct. Notice I never write that leading zero. I don't know why they do.
Okay.
To me, it's a waste of pencil space and paper space. It's always zero, right? I mean, it's not needed any more than a leading 1 is needed for this x over here on the lower left. So I don't write it. Now, B and C are the price of beef and chicken. So that's why we made B equal to C. It's because that's what they're asking for, is what is X going to be, which is the price per pound of...
Yeah, to make them equal.
Yeah. Yeah, very interesting, tricky question there. In other words, you set it up correctly, and we're going to solve for X, but notice what X is. X is the number of weeks after July 1st. We're going to answer when the price of beef is equal to the price of chicken. Okay? Now, I'm not worried about you solving this equation. I'm sure you can do that. But notice that X is not what they want. They want, what is the price per pound of beef when it was equal to the price per pound of chicken? So when you solve for X, you got to go back in to the B equation, the beef equation, substitute it, and figure out what the price per pound of beef was. You could actually also substitute into the chicken equation because it's going to be the same. Equal. Well, it's going to be the same, yeah. Whatever B ends up being, same as C would be. And actually, that equation is a little simpler. Might be easier to take our answer and substitute it into that one. But to understand the concept of the problem, you definitely want to substitute it in for the price per pound of beef.
Yeah. Let's do this quick because I don't want to make you late for your...
What's the first step solving this equation?
Well, you combine the two whole numbers, right? That's what I was thinking.
Yeah, and it's best to put the numbers and the variables on the respective sides that decrease negative signs. So I'm going to bring the numbers over here, and I'm going to bring the variables over there. No negative signs. If I'd have done it in the opposite direction, I'd have had negative signs on both. Okay. Now, that goes into that 4 times. So X, 4 weeks after July 1st is when these two things are equal, and so that's really easy to plug in 4.
Yeah, so it's yeah, it's 1 plus, so it's 335.
Correct. Notice how tricky that problem was.
Yeah.
Intentionally tricky. All right. I'm going to keep a log file on you so that I'll know exactly where we got to on these tests. And
Okay.
anytime you don't have schoolwork, you know, something from class that you need to cover, we'll go back and do 5 or 6 questions on this thing.
Okay. Sweet.
Okay? All right.
Okay. See ya.
Talk to you later. Bye-bye.
See ya.